Well, hello. Um, I want to use this very short video, not very short, maybe 10 minutes, 15 minutes, to finish 4.4, section 4.4. 4.4. It's about moving entities and landscape interaction. Specifically, this model I want to discuss here is a simple model of foraging with regrowth of resources within the lattice, within that lattice. Okay. Um, Previously, we discussed models with a forager and some resources randomly distributed within the space. But once the resources of a specific cell has been consumed, it will be empty forever. But here we want to add more interaction um, into the relationship between the forager and the landscape. Okay, so section 4.4 is about moving entities and landscape interaction. This interaction was there in previous models because foragers um, they need to collect resources from this virtual world here, right? But now we add another factor into this world, which means that the resources they can regrow after a specific time period. Okay, this model here is to illustrate firstly influence of spatial dynamics on foraging. This dynamic is actually the regrowth of resources of food, right? And the secondly, a role of persistence versus random search. Okay, how about this model? How about the rules? First, the forager first takes the resources at its current location. Okay, at the very start, the forager will stand on a specific cell that has resources. It will take the resources first. Okay, and it then moves by picking the closest site, which currently has resources available. Meanwhile, resources grow on a random site. So you can set a vision for this forager, which means that within this vision, all the cells within this vision, their information is available to this forager. And the forager will pick the site with resources and go to that site. But within this vision, there are many sites with resources. Which one to choose? The closest one. Okay, and the one this forager is going to the closest site, closest cell with resources. Another cell will be assigned with some resources randomly within this world. Resources regrow periodically after being visited. Okay, so at the very beginning, the forager will collect the resources from the current site, which means this current site has been visited. It will keep visited for a time period. And after that time period, immediately resources will respawn, will regrow on this site. So this visited time period is actually a period to make sure that resources will not regrow. Okay, but after this time period, after this visited time, after this cell is flagged with being visited, resources will immediately regrow on this site. So that is regrowth of resources. So visited sites persist for n steps, right? So this persistence of n steps is actually the time period that this site, that some sites maybe, they are being flagged as being visited and resources will not respawn, will not regrow within this persistence, within this n steps. Okay, of course you can set this specific n value. Okay, so we have a model from the textbook. Actually, the model right here is implemented in NetLogo. Is 4.6. Okay, let me show you this model very quickly. So this is actually the model. And when you load it, a spatial pattern of resources, can you see that all those cells with green color, those cells, they are cells with resources. And you can see here, there is an orange circle here. And actually, there is also a black icon below, I mean, covered by this orange circle. It doesn't matter. It actually means that the forager is right here, that black one. But here it is orange because it means that after this step, the resources from this site will be collected by forager. And if you click step, so next step, you can say that the green cell is not there anymore. It is replaced by this orange circle, which means that resources is not there anymore. And this specific site will be flagged as being visited for how many steps? You can set the n steps, 200 steps, which means that in the next 199 steps, resources will not respawn at this site. But after that n steps, resources will be back. Okay, and if we click step, okay, the forager will go to the next nearest site with resources and eat it, and or you can say collect it, or any verb you want. And so if I click, say, it will search and collect available resources. And simultaneously, you can say there are sites with resources available randomly within this space. Each step here, this one was not there. This one used to be a white cell without any resources before the previous step, but now it is the one with resources. Okay, so after each step, a cell or a site with resources will be invaded by this forager, but simultaneously another cell will be given resources to make sure that this word is always with resources, okay? And yeah, if you click go, you can say that we have more and more orange sites, which means they have been the resources of them have been collected. And we have run this model for 371 steps. And you can see at the very beginning, the forager was right here, right around this area, and a lot of cells, green cells within this area indicated by my cursor here, used to be full of orange circles, but now they're not there anymore. And we can say that new resources have been assigned to this area because the 200 step time period has passed. So now, for now, at the top of this lattice, we can see a lot of orange circles here, which means the resources within this area have been collected recently. But if we let it go after 200 steps, let's just stop around 571. How about now? It's empty. It's empty. All those cells who were flagged as being visited, they are not flagged as being visited anymore, which means at any step, they could be assigned with some new resources because this process is random, but at least they can have new resources. But all those cells are being flagged as visited, or you can say cells with orange circles, they cannot be assigned with new resources. And about this vision range, you can change it actually, but it doesn't affect anything because the principle here for the forager is that you choose the closest site with resources and go there. Even you change it to 1, it will search all those cells 1 unit distance within 1 unit distance to say if there is resource. And if there is, choose the closest one. Also, it must be a cell 1 unit away from this current from the location of the from the current location of the forager, because the vision range is 1. But if you change it to 20, I mean, it means that the forager has the information of all sites within 20 unit distance. But it doesn't make sense. It's not necessary, because even you have so much information compared to a forager with a vision of 1, you will still go to the closest site, right, with resources. So you can change it, but I don't think that the behavior of the forager will change. You can try. I tried, and it's the same. Okay, it's the same. And setup, you can say here, another tricky part about this model is that if you load it, for example, I discard the change and reload it again, foraging with regrowth. Okay, here setup, you have a spatial pattern of resources here right now, right? And even you go and set up again, you will have the same pattern. You can click it as many as possible. That's because if you go to the code, you will see that, yes, random seed. This spatial pattern is a seed from a group of seeds, from 10 possible seeds, which means that once you load this model, you have loaded this model, this spatial pattern of resources here will not change. How to change it? You load it again. So this is the interesting part of this. And you cannot change, you cannot choose if you want to randomly create a spatial pattern or use a seed to assign this specific pattern. But yeah, you can say once you load this model, this pattern has been decided, that seed has been decided. Okay, that's an interesting part of this. Okay, and once you click go, you can repeat this process many times. You will see that the behavior of this forager stays the same. Even you change it back to 1, set up and go, you'll see that. The only randomness here is there is still randomness. So what do you think is the randomness here? It is the new site with resources. For example, this was the 1, right? If you set up and step again, okay, let me repeat this process. Set up, step 1. So this is a cell. This is a site with resources. This is a new one. Okay. So what's the next one? Somewhere here, right? And where is the next one? Here. So if I set up, I just reset up it and step again. You can see that for this specific seed, it's still this style, this site will be assigned resources after the first step. So if you repeatedly run this model, you'll see that there is no randomness at all. That's because this code here, if you read them, if you read this code, you will see that all have been decided. So this is the disadvantage of this model. And if you choose this model and reload it again, of course, I mean, I'm not even sure. Yeah, it's the same one. You can say that. But you should know that you can change that. Okay, the initial spatial pattern of resources can be changed. And of course, you can choose a random cell after each step to assign resources instead of giving the same one here, because this model right here in NetLogo, model 4.6, has been designed to repeat the same process of assigning initial resources and assign resources to new sites after each step. it has been decided by this specific model, but you should know when you are using this type of model, you can add randomness into this model. For example, initially, you will ask the program to randomly produce a spatial pattern or spatial distribution of resources and assign this forager at a random location with resources. And also after each step, you can assign a randomly chosen site to give it resources. And you can also design this program to make sure that after each setup, the new spatial pattern of resources is again random. Okay, but for this model, I just want to make sure you know that this model specifically 4.6, it has been designed to reduce randomness. Okay, at each loading, your spatial pattern of resources is decided by this random seed value. Okay, let's get back. So implications of this model. Foraging success requires not adhering to a fixed route. Although if you run model 4.6, it's a fixed route, okay? But you can change it. For example, you can say what? You can say, I'm not going to choose the nearest site with resources to go there and collect. I can randomly choose any site within my vision that has resources and go there and collect resources and repeat this process, right? And also retaining some randomness allows forager to identify new resources. Okay, so if we compare the model I'm introducing right now in section 4.4 to other models, especially a model from 4.3, the monkey searching model, we can say that the difference is enhanced interaction between the forager and the landscape, because here we will just assign resources to random sites dynamically during this simulation. And also when a site has been visited, it will keep being visited for some time to make sure that new resources will not be assigned to this newly visited sites. It's closer to the real world, right? If you have harvested something from a specific area, you cut down a tree, right? It's not possible to just plant a tree and let it grow to be a big tree in one day, right? That area, that tree has been cut down. That area will be empty for years to have a new big tree, right? So that's the difference. Okay, like I said, this is a very short video compared to other videos I made for this class. It only includes the content of section 4.4. And from next video, I will talk about flocking, how to simulate flocking behavior, or how to simulate entity to entity interaction. Okay, thank you.